Space exploration is a remarkable endeavor that pushes the boundaries of human knowledge and technology. However, it is not without risks. Exploring space is inherently challenging and dangerous, involving complex systems, extreme conditions, and significant distances from Earth. Here are 10 notable risks associated with space exploration. 1. Launch failures. One of the most critical risks in space exploration is launch failures. Rockets are complex machines with multiple stages and intricate systems. Any malfunction during launch can lead to catastrophic accidents, resulting in the loss of spacecraft and crew. Example: the Space Shuttle Challenger disaster in 1986 was caused by the failure of an O-ring seal, resulting in the explosion of the shuttle shortly after liftoff and the loss of all 7 crew members. 2. Microgravity effects on human health. Long-duration space missions expose astronauts to microgravity, which can have adverse effects on human health. These effects include muscle atrophy, bone density loss, vision impairments, and changes in the cardiovascular system. Example: some astronauts who spent extended periods on the International Space Station, ISS, experienced vision problems and changes in their eyes' shape. 3. Radiation exposure. Beyond Earth's protective atmosphere, space travelers are exposed to higher levels of cosmic radiation, which can damage cells and increase the risk of cancer and other health issues. Example: Mars missions would expose astronauts to prolonged radiation exposure due to the absence of a thick atmosphere and magnetic field on the planet. 4. Space debris. Space is littered with debris from previous missions and satellite collisions. Space debris poses a collision risk to spacecraft, satellites, and the ISS, potentially causing damage or catastrophic failures. Example: in 2009, an inactive Russian satellite collided with an active Iridium communications satellite, generating thousands of fragments that increased the space debris risk. 5. Human error. Space missions involve complex operations, and human error can lead to critical mistakes that jeopardize the success of the mission and the safety of the crew. Example: the Hubble Space Telescope's initial blurry images were due to a mirror defect caused by human error during the manufacturing process. 6. Life support system failures. Spacecraft and space stations rely on life support systems to provide astronauts with breathable air, water, and temperature regulation. Malfunctions in these systems can endanger the crew's survival. Top 10 space exploration risks in the world on the Apollo 13 mission. An oxygen tank explosion jeopardized the astronauts' life support systems, requiring a dramatic and innovative rescue effort. 7. Re-entry and landing risks. Re-entering Earth's atmosphere is a critical phase of a space mission. The intense heat generated during re-entry can pose risks to the spacecraft and crew, and precise landing is essential to ensure a safe return. Example: during the re-entry of the Space Shuttle Columbia in 2003, damage to the thermal protection system resulted in the disintegration of the shuttle, leading to the loss of all 7 crew members. 8. Isolation and psychological challenges. Space missions, especially deep space exploration, can isolate astronauts from Earth for extended periods. The psychological challenges of isolation, confinement, and distance from loved ones can impact the mental health of crew members. Example: psychological studies of astronauts on long-duration missions have revealed challenges related to confinement, stress, and social isolation. 9. Limited resources and self-sufficiency. Space missions require careful management of resources, including food, water, and supplies. Crews must be self-sufficient and able to address emergencies without immediate assistance from Earth. Example: the Mars 1 mission concept faced criticism due to concerns about the feasibility of maintaining self-sufficiency and adequate resources on Mars. 10. Planetary contamination. Space missions that involve landing on celestial bodies like Mars must take precautions to prevent contamination. Bringing Earth microbes to other planets could hinder the search for potential extraterrestrial life. Example: the Viking landers on Mars in the 1970s conducted experiments to detect signs of life, but their results were inconclusive partly due to concerns about potential contamination. Despite the risks, space exploration has yielded immense scientific knowledge, technological advancements, and inspiration for future generations. Mitigating these risks requires rigorous safety protocols, continuous research, and international collaboration. Robust testing and redundancy in spacecraft design, rigorous astronaut training, and constant monitoring of crew health are essential to ensure successful and safe space missions. Advancements in robotics and artificial intelligence may also play a crucial role in reducing human exposure to risks during space exploration. As humanity ventures further into the cosmos, the awareness of these risks and the commitment to safety will remain paramount in shaping the future of space exploration.